Glycine is the fourth most abundant amino acid in proteins. Around 7% of proteins, 7% of amino acids in proteins is glycine. I already just searched for it here. It's the simplest amino acid. I was going to say neither one's, the side chain is identical to the non-side chain, but since it is still the left-handed version, technically the hydrogen in the front is the side chain and the hydrogen in the back is the normal hydrogen. So here is the alpha carbon, just to kind of orient you. Alpha carbon amino group, carboxylic acid group. The word glycine comes from the Greek for sweet, and still in modern Greek it's glycos. So you can see that's kind of the root, glyc, and that's used for a lot of things. Sugar, glucose, with the same root or prefix. The abbreviation GLY or G for the single letter. The biosynthesis for glycine yeah, so glycine can be created from serine. So there's a pathway to create serine, and then you can create glycine from serine. So serine is non-essential. Glycine is also non-essential in the human body. Sorry for the long pauses. This is the alpha helix table here of essentially the most favorable amino acids. Other than proline, glycine is the least favorable amino acid for incorporating into an alpha helix. I think there's some conflicting information here that kind of makes it sound like glycine is very important for alpha helices, so I'm not really sure. It sounds like it is common in an alpha helix, even though it's not favorable in an alpha helix. I think it's yeah, so if you look at the protein collagen, which is a structural protein in the extracellular matrix, constituting like 25 to 35% of the protein in mammals. So a large portion of all mammals is collagen, and a large portion of collagen is glycine. So abundance in mammal skin, I guess that's like 33% of the amino acids are roughly glycine. So there's this glycine proline or hydroxyproline motif that shows up. I thought it was at the bend, so like if you had an alpha helix, you'd have a beta turn or something like that between alpha helices. And I think that's where this glycine proline might also show up, but it's kind of just maybe a repeating pattern in collagen as well. Glycine is neither hydrophobic or hydrophilic. It kind of can go either way. Just because it has a very minimal side chain, it's not going to really complain about being in either situation. I think that's pretty much it.